Welcome to the Explainer. Today, we're going to talk about something that feels like straight up magic, but it's all physics, the air conditioner. And hey, if you're in building design or, staring down an exam like the NCARB AR, then you're going to want to pay close attention. We're going to break down how this thing really works.
So let's just jump right in with the biggest question, the one everyone gets wrong. Does an air conditioner actually make cold air? I mean, you flip a switch, cold air blows out. It's gotta be creating that coldness, right? Like there's a little ice machine humming away in there?
Well, the answer is a big, fat nope. It's kind of wild, but an AC doesn't make cold at all. A better way to think about it, it's a heat pump. Or, even better, it's a heat thief. Its whole job is to run a little heist, steal the heat from inside your room, and then dump it outside where you don't care about it. Seriously, if you get this one idea, that we're moving heat, not making cold, you've basically unlocked the secret to the whole system.
Okay, so how does it pull off this heat heist? It all comes down to a super simple principle you already know, evaporative cooling. You know when you get out of a pool and feel a chill, or when you sweat? That's it. As the water evaporates off your skin, it literally pulls heat away from your body to turn from a liquid into a gas. Your AC does the exact same thing, just way more efficiently. Instead of sweat, it uses a special fluid called a refrigerant.
All right, here's what we're gonna cover. First, we'll nail down that core heat heist concept. Then we'll meet the 4 key players in the system. After that, we'll follow a particle of refrigerant on its crazy journey. Then, we've got a killer exam cheat sheet for you. And we'll wrap up with a final twist on how this all works. Let's do it.
Okay, section 1, the core concept. Remember, it's all about the heat heist. We're not making cold, we are moving heat.
So yeah, an air conditioner is just a device that uses electrical energy to pump heat from inside to outside. That's it. That's the whole job. All that machinery, all that electricity it's sucking up, it's all for one purpose. Grab heat from inside your space and dump it outside. Pretty simple when you think about it that way.
Okay, section 2. Now, our little refrigerants can't pull off this heist all by itself, right? It needs a crew, a team of 4 key players that make this whole thing happen. Let's meet the 4 musketeers of refrigeration. You've got the evaporator, that's the heat absorber inside. Then there's the compressor, think of it as the heart, the engine of the whole operation. Outside, you have the condenser, which is the heat dumper. And last but not least, the expansion device. That's kind of like the reset button for the whole cycle. These 4 work together in a perfect loop. All right, section 3, this is where the action happens. Let's follow one little particle of refrigerant on its epic journey through the system. We're going to see exactly how it steals that heat and gets it outside. So our journey kicks off inside your room at the evaporator. A fan is blowing your warm, sticky room air over these coils. And inside those coils is our refrigerant, which is a super cold, low-pressure liquid. As that warm air hits the cold coil, the refrigerant instantly starts to boil. It turns from a liquid to a gas, and in doing so, it just sucks up a ton of heat, and humidity, by the way, from your room's air. So you can see what's happening right here. Before the evaporator, it's a cold, low-pressure liquid and gas mix. After passing through and boiling, it's now a cool, low-pressure gas. The key thing is it's now carrying all that heat it just stole from your room. Mission accomplished, part 1. Okay, step 2. That cool, low-pressure gas, now loaded up with heat, heads over to the compressor. Now this is the heart of the whole system. It's the big power consumer, and its job is simple but brutal. It takes that gas and squeezes it. It compresses it a lot. And you'll see why that's so important in a second. You know how when you use a can of spray paint or compressed air, the can gets really cold? That's because the pressure is dropping really fast. Well, the compressor does the exact opposite. By jacking up the pressure, it also jacks up the temperature. It makes that refrigerant gas super, super hot, way hotter than the air outside. And this chart just says it all. It goes in as a cool, low-pressure gas. It comes out as a crazy hot, high-pressure gas. We're talking like 80 degrees Celsius or more. Now it's carrying all that indoor heat, and it's ready to dump it. So this super hot gas now travels to the outdoor unit, to the condenser. And that big fan on the outdoor unit starts blowing outside air across the coils. Since our refrigerant is way hotter than the air, heat just naturally radiates away from it into the atmosphere. That's the blast of hot air you feel if you stand over your AC unit. As it gets rid of all that heat, the refrigerant cools down and condenses back into a liquid. Okay, we're almost home. Our refrigerant is now a warm, high-pressure liquid. It's gotten rid of the heat from inside, but it's still not cold enough to go back and get more, so it heads to the final piece of the puzzle,
the expansion device. And really, this is just a tiny, narrow valve. Think of it like putting your thumb over the end of a garden hose.
And this is the magic reset. As that high-pressure liquid gets squeezed through that tiny opening, the pressure on the other side just plummets. And just like with the spray can, when the pressure drops, the temperature drops a lot. Suddenly, it's back to being that super cold, low-pressure liquid we started with. It's ready to head back to the evaporator and steal some more heat. The cycle is complete and starts all over again.
Okay, section 4. This is your exam cheat sheet. Pencils ready, we're going to cover the key concepts you absolutely need to know for the ARE or any other professional exam. All right, 2 words you are guaranteed to see: superheat and subcooling. They sound complicated, but they're just safety checks. Superheat happens at the end of the evaporator. You want the gas to be just a little bit warmer than its boiling point to make absolutely sure there's no liquid going into the compressor. Liquid will wreck a compressor. Subcooling happens at the end of the condenser. You want the liquid to be a little cooler than its condensation point to make sure only pure liquid enters the expansion valve. This keeps the whole system stable. The target for both is about 5 to 10 Kelvin, which for a temperature difference is the same as Celsius. Get these numbers wrong and you're either damaging the machine or just wasting a ton of energy.
So what are the common ways these things fail? For your exams, just remember these 3 killers. 1, clogged air filters. Super common. It chokes the airflow and the indoor coil can literally turn into a block of ice. 2, wrong amount of refrigerant. Too much or too little, and the whole system's performance just goes down the drain. 3, low airflow in general, maybe from a dirty fan. If you're not moving air, you're not moving heat. Simple as that.
Okay, another classic exam question: constant speed versus inverter units. Your old school AC is either on or off, full blast or nothing. An inverter unit is way smarter. It can change the speed of the compressor, kind of like a dimmer switch for your lights. The bottom line: inverters are way more efficient, they're much better at controlling humidity, and they're a whole lot quieter. It's a huge step up.
All right, section 5, the final twist. So far, we've talked about this amazing system for moving heat from inside to outside. But what if we could flip a switch and run the whole thing backwards? And that, my friends, is what a heat pump does. You add one clever little part called a reversing valve, and it literally reverses the flow of refrigerant. All of a sudden, the outdoor unit becomes the evaporator. It starts stealing heat from the cold outside air. Yes, even when it's cold, there's heat energy to grab. Then it sends that heat inside, where your indoor unit becomes the condenser, dumping that heat into your room. You are literally heating your home by air conditioning the outside world. How cool is that? So when you boil it all down, what's the one thing a designer, an architect, an engineer really needs to remember from all this? It's this: stop thinking of an air conditioner as a cooling machine. It is a heat-moving machine. Master the cycle, and you master thermal comfort. Once you really get that, you're not just picking a piece of equipment anymore. You're actually designing how energy moves through your building, and that changes everything. So the big takeaway is, don't just ask how to make a space cold. Ask, where does the heat want to go, and how can I help it get there?